We all love word problems, so here's a good one for you. The hypotenuse of a right triangle is 6 inches longer than the shorter leg. The longer leg is 3 inches longer than the shorter leg. Find the length of the shorter leg. Okay, let's break this down. Let me show you what I would do. First thing, I'm going to draw a picture, right? So the hypotenuse of the right triangle, that's going to be my longest side. So I'm just going to draw a right triangle. Hypotenuse is always opposite of the 90. So that's this side right here. This is my hypotenuse. And what we know about it is said in the information here. Hypotenuse of the right triangle is 6 inches longer than the shorter leg. So this is our shorter leg. These are our two legs, okay? This one's clearly shorter. So let's just label it A. So my hypotenuse is 6 inches longer than that. So I'm just gonna say A plus 6. That's my distance right now, but hopefully I can figure out what A is, and then I'll know what all my side lengths are. Okay, the longer leg, so that's this leg. Remember, this is a leg, this is a leg, this is our hypotenuse. So A, in comparison to this one's 3 inches longer. So I'm gonna say A plus 3. It's just 3 more than whatever A is. The hypotenuse is 6 more than whatever A is. Our job is to figure out what A is. Okay, so what I wanna do now is I'm gonna use the Pythagorean theorem, which is A squared plus B squared equals C squared. For A, that's this leg, and then B, we're gonna be using this leg. C is gonna be our hypotenuse. I'm gonna plug my information in. So A needs to be squared, plus B, which is A plus 3 squared. That's gonna be put in parentheses, A plus 3 squared, equals C, which is A plus 6, but we gotta square it, so A plus 6 squared. That's how I would set this equation up. Now I need to start solving it, and what I'm gonna end up with is a quadratic, and then I'll have to solve that quadratic, whether it's factoring, completing the square, putting it in the quadratic formula. We'll make that decision once we see what the quadratic looks like. Okay, so A squared is just A squared. This is where kids tend to make mistakes. A plus 3 squared, sometimes I'll have kids wanna distribute the exponent. You want to think of this as A plus 3 times A plus 3. And when we do that, we need to use the FOIL method. So what you're going to end up getting is A squared plus 6A plus 9. That's what we're going to end up getting when we square A plus 3. So that's going to go down right here. Plus another A squared plus 6A plus 9 plus 6A plus 9. And then same idea on the right side of the equal sign, A plus 6 squared. A plus 6 squared is written out A plus 6 times A plus 6. And I'll go through this one a little bit more clear for you if you were confused by how I got this information. We got to use the FOIL method. First terms multiply together. A times A makes A squared. Then I got to do A times 6, which is 6A. 6 times A again, and then 6 times 6. So what this is going to end up giving me is A squared plus 12A plus 36. All that information needs to go on the right side of the equal sign. So A squared plus 12A plus 36. A squared plus 12A plus 36. Now you've got this long equation, and we got to set it equal to 0. So I got to take all of the information on the right side and push it over to the left. So the opposite or the inverse of A squared is negative A squared, and that will cancel that out. So I've got 2 A's over here, 2 A squareds. So I'm just going to change that. I'm going to combine my like terms real quick. A squared plus A squared makes 2A squared, but remember I'm about to take A squared away. I'm going to take one of those away, leaving me with just one left. Okay, now we got to get rid of the term that has just an A. That's a 12A. I want to get rid of it, so I'm going to say minus 12A. Inverse operate, take it away from the common term or like term over here. 6 minus 12 gives me negative 6A. And last but not least, we get rid of the constant. Plus 36, the inverse would be minus 36. That will cancel it. Notice everything on the right side is about to cancel. So we're going to end up getting equal to 0, which is what we want. Minus 36 from the 9. and that's going to leave me with negative 27. Okay, so now that I've set this up, after I've put everything into the Pythagorean theorem, A, I squared it. B, which was written as a binomial squared, came out to a trinomial. Then our hypotenuse, a plus 6, which was written as a binomial squared, came out as a trinomial. We removed everything from the right side so that we could have our quadratic setup equal to 0. And now we can use this to solve for A. We're going to solve this quadratic like we would any other quadratic. Okay, you can make the decision on your end if you want to factor it, complete the square, graph it. There's so many different methods of solving a quadratic. I'm going to look at this one and I decide to factor. Okay, so I'm going to rewrite this up here so we can factor it out going down. A squared minus 6a minus 27 equals 0. Now, if you know what you're doing when it comes to quadratics and how to solve them, I'm looking at these numbers right here and I get excited when I see those because I'm already thinking of two numbers that multiply together to make negative 27, but when I add them together, I'm going to get negative 6. Two numbers that multiply together to make negative 27, but add together to make negative 6. I want you to try and think of what those are right now while I start factoring it out. Hopefully you've had enough time to determine what those two values are. A squared in the front is going to come from an A here and an A here in our first terms. Now in these two terms, the second terms of each binomial, I need two numbers that multiply together to make negative 27, but will add together to make negative 6. This is called factoring. Okay, if you're being asked to do this, a question like this, you definitely should know how to factor by now. Okay, and those two numbers are going to be a negative 9 and a positive 3. Okay, negative 9 times 3 makes negative 27. And then negative 9 times a is going to give me negative 9a. And then a times that 3 is going to give me a positive 3a. And when I combine those two terms, I'm going to get my negative 6a that we see in the middle there. Okay, so now that I have this set up as two binomials, remember it's set equal to 0. Remember that this quadratic was set equal to 0. So we use our zero product rule. What number would a have to be here to make a 0 in the parentheses? What number minus 9 makes 0? A could be a 9, or a could be a. Over here, what number would a have to be? What number plus 3 would make a 0? That would be a negative 3. Now, a lot of times in a real life example like this, we got to ask ourselves which one of these two solutions makes sense. If a is our distance from there to there, does it make sense to say that a is negative 3? No, distance can't be negative. You can't say negative 3 inches. It doesn't make any sense, right? So we have to use the positive value, meaning this is really not helpful for this problem, but the other solution is extremely helpful. It tells us that our triangle that we originally drew out from the words is going to have an a value of 9. Keep in mind that the longer leg was supposed to be 3 inches longer than the shorter. So what's a plus 3? That's going to give me 12. Okay, 9 was a plus 3. 9 plus 3 makes 12. And then remember the hypotenuse is supposed to be 6 larger than the smallest leg. So a plus 6 would give me my hypotenuse. Well, what's 9 plus 6? 15. Okay, now if we look at this, would 9 squared plus 12 squared equal 15 squared? We can double check our work real fast and see if it comes out the way it should. And double check, is 12 3 more than 9? Yes. Is 15 6 more than 9? Yes. Let's just make sure it gives us the right triangle. 9 squared is 81 plus 12 squared, which is 144, equals 15 squared, which is 225. 81 plus 144 equals 225. Checks. Everything that we just determined is correct. Okay, so it's a word problem. Gets trickier when you got words, right? What's the first thing I did? I went over and I drew a picture, labeled what I knew, plugged it into the Pythagorean theorem, solved that out, and then once I had my quadratic, I chose to factor that quadratic. Now, if factoring is not the route you want to take, if you'd rather just plug it into the quadratic formula, you would have got the same two results. You would have got 9 and -3. I think it was a -3, right? Okay, so 9 and -3 would have been those two values you would have got. Same idea. Does it make sense to use -3 when we're talking about distance? No, it doesn't. So stick with what you know, study hard. You can do it. Good luck on your upcoming test.